what is this? What do you see? Yeah. Well, it's a function, right? It tells you it's a function by being in f of x form. But what is it? It's a general form of exponential, right? What does a represent? Yes, that's exactly right. The starting value. And what does b represent? The ratio, right? You remember talking about all that kind of stuff? All right, so this is exponential form. This is recursive form. Well, how about if I write before I talk? No, it's my fault. This is r times f of n minus 1. Sometimes I can talk and write, sometimes not. Okay? So this is exponential form, this is recursive form. Now this is recursive form of an exponential function, so it's like a different way to write this. Okay? So if I tell you f of x equals 2 times 3 to the x power, I need you to be able to write that in recursive form. Do you think you can? What do these represent again? The starting value and the ratio, right? Well, guess what f of 0 represents in recursive form? That's a. That's where you start, right? Do we know a? Yeah. So in this problem, f of 0 would be 2. Okay? What about f of n? Any number that we want in the recursive form. Do we know r? What does r represent? What did I tell you it represented? The ratio? Oh, so that's just b, isn't it? So 3 times f of n minus 1? Okay, done. Yeah. Yeah. Guys, just because it's different doesn't mean it's harder. It's just different. No, that's it, right? Now, the thing comes like if I say a lot of people, including myself, I like this one, okay? Because if I say to you, what is f of 4? What am I going to do? 2 times 3 to the 4th. Well, what is 3 to the 4th? 81. What's 81 times 2? 162. Well, if I'm trying to find f of 4, here's what I have to do. I know f of 0 is 2, so first I have to find f of 1, which is 3 times f of 1 minus 1, which is 3 times f of 0. Do I know f of 0? Oh, it's 2, so 3 times 2, 6. Then I have to find f of 2, 3 times f of 2 minus 1, which is 3 times f of 1. But I know f of 1, that's easy, that's 6. Oops. And then 6 times 3, which is right. No, you were right. 18. I just wrote the wrong thing. And then we have f of 3. We're almost there, right? 3 times f of 3 minus 1. 3 minus 1 is 2, so 3 times f of 2. Well, f of 2 is 18. What's 3 times 18? 54. And then I have f of 4, which is 3 times f of 4 minus 1, which is 3 times f of 3. And f of 3 is 54, so what's 3 times 54? 162. Because if we're doing recursive functions, the way that this general form is set up is I have to know the term before it. So if I'm trying to find f of 4, I've got to know f of 3. But in this particular case, I only know f of 0. So then I have to find f of 3, but then I also have to know f of 2 and f of 1 to be able to use f of 0 and go back up the list. Does that make sense? Now, there's a lot of situations where where recursive functions are really nice. There's even recursive functions set up where you have to know the previous 2 terms. Okay? Have you ever seen this before? Have you ever seen this series of numbers before? Do you know what it's called? It has a special name. Can somebody tell me the next number? 21. Where does this list come from?
You add, then add, and then add. So it's 3, and then add, and add is 8, and then add is 21.
So what's the next term then? 34, right? So it's the previous two numbers added together. Doesn't that seem like a recursive function? That seems like it would be f of 0 is 1, and so f of 1 is f of 2 minus, well, let's see, f of 1 would have to be 1, and f of 2 would have to be f of n minus 2 plus f of n minus 1, right? You'd have to be given the first two terms, wouldn't you? So f of 2 would be f of 0 plus f of 1. Well, what's 0 plus 1? 2. Well, what about f of 3? That would be f of 2 plus f of 1. Or 1 plus 2, right? So in this case, 2 plus 1, which is 3. Does that make sense? Kind of? So there are recursive functions that occur. This is probably not exactly right because I was just doing it off the top of my head. So if it's not exactly right, I apologize. But you get the idea that I'm trying to tell you, right? Okay, so this kind of thing is useful in situations, but a lot of the situations we've been talking about with exponential stuff, a lot of people find this one much easier to use. So why did I even show you recursive functions? So you know what happens, you know what to do, and because it says, right? Teague say, I need to talk to you about recursive functions, and so I did. I followed directions. This time. Just teasing. Okay? Any questions about this?